Starting a new project. Going to call it Juno 34. And you guessed it, it's outside of Juneau, Alaska. Starting a new project, we immediately come into this project information page, but our project location here, our information's empty. If you've got exact information, you can paste it in, but we're going to go over here to the right and hit Find Location on Map. We're going to search for Egan Drive, J-U-N, and there we go. Autocomplete suggests locations, top of the list. Takes us to just outside of Juneau. There's our site. Risk category 2 should be fine for a home. We'll go with the assumed D default stiff soil for now. And yeah, let's see all the load types. Hit view results. And those load really quickly. Here we go. We've got a wind speed 122 miles an hour. That's about what I expected. And we got moderately high seismic here. And serious ground snow load. Okay, we hit save. This will bring us back to the project information screen. And we'll see that, yeah, we got our information for the location in. And over on the right, we've got a new option. Let's see the report. We've got a one-page summary, wind, seismic, snow. And then if we hit hazard, we've got a little bit more detailed report with pinpoint on the location and all the information coming out of the ASCE 7 query. All right, hit close. We'll go back to the project, and we don't have any design modules, but we want those design loads first. So over here on the right, we've got our load calculators. If we go into seismic load, and this is already set up for us, we're not overriding the project defaults, meaning we are accepting the information from that query we just did. So here's that 0.54, 0.4, 12-second long period transition. And for our structure, we have two levels. First level is 12 foot tall, second is 10. First level 87, yes, 87 kips. And the second was 43,000 for that lump sum at the roof. Yeah, there we go. We've got this diagram. Perfect. Now, these forces are wrong, and that's because we haven't told it what kind of structure we have yet. If we come down here, we could put in a custom building period. I haven't gotten that deep on the analyses yet, so let's get this seismic force resisting system updated. We do not have intermediate precast shear walls, but at the bottom down here, we have timber frames. And yeah, that's a low R value, so whoa. 44 kips of base shear we see here in the bottom right, and seismic design category D. So game on. We go back. We can go into our wing load calculators. We've got one for main wind force resisting system. Override the project defaults is set to yes. Let's set it to no. And there we go. It knows we need ASCE 716, and that's our wind speed 122.3 miles per hour. We're actually going to be C here is a gable roof. It is 70 foot long, 40 foot wide, 612. Top of roof, I think, was at 28 feet. Gives us 23 mean roof height. That's correct. Let's see. We're going to auto determine the ground elevation. There is no hill. We are in enclosed structure here. And there we go. All of those wind pressures, all automatically calculated. Here they are for us. And if we hit the printer icon, yeah, there we go. A 3-page report with a diagram to get us oriented, all the pressures tabulated, all the background parameters and input. Can't ask for more. We go back to the project. We can do the same thing in our components and cladding. Brings in automatically our wind speed. Cable 70, 46, and 28. And here's our log graph. Gives us the pressure coefficient. In fact, this gives us the pressure for every different zone dependent on the effective wind area. All that's tabulated for us as well down here. Oh, I forgot to turn it to enclose. I saw that 0.55 telltale. There we go, 0.18. There's our enclosed internal pressure coefficient. Perfect. We go up here to the printer icon. Once again, we get this nice compact report. Everything's tabulated, ready to submit. And all of these loads that we're loading here can be automatically brought in to all of the modules where we can design beams, walls, columns, etc. All right, we're not overriding here. Yeah, it automatically brings in our 60 PSF. Okay, upper roof length 50, 20. There is a 4-foot step. We don't have any projections or parapets. It is an unobstructed slippery surface, and that gives us, whoa, 95 PSF for the lower roof snow drift. And then it also summarizes the snow height, unbalanced snow, and the balanced snow loads. Once again, hit that printer icon. Everything summarized right here. Perfect. Now we're ready to design this structure.